Mathematics 10, I will be discussing theorems on inscribed angles. I will be discussing about a maximum of 4 topics or 4 kinds of theorems on inscribed angles. But before we discuss those 4 topics, you must know, or we should know, what theorems are and inscribed angle is. So what is a theorem? A theorem is in mathematics and logic, a theorem is a non-self-evident statement that has been yet to be proven or to be true as a result that has been proven to be true using operation and facts that were already known. An inscribed angle is an angle whose vertex is on the circle whose sides contain chords of the circles. So here in the example, our line C and A are the chords, and line AD is the chord. With these two lines forming an angle, this would be our inscribed angle. So our angle would be angle CAD, the inscribed angle. And this red line here is our arc, and our arc in here is arc CD. Moving on to our first theorem. Okay, now that we are done discussing what a theorem and an inscribed angle is, we will be discussing the first theorem. So in our first theorem here, it says that the measure of the inscribed angle is equal to 1/2 of its intercepted arc, or the measure of the intercepted arc is twice the measure of the inscribed angle. So here in the examples I will be showing, it's already given here that arc CT is equal to 86 degrees, and angle CAT is our inscribed angle. So it says here, and find the value of angle CAT. So our solution here will be angle CAT equal to 1/2 and times arc CT. So we move on to substitution. Angle CAT equal to 1/2. Substitute our given arc CT is equal to 86 degrees, and angle CAT will be equal to 43 degrees. So therefore, angle CAT is 43 degrees. After substituting here, we just simply divided 1/2 of the 86 degrees, or the arc, because it says here the measure of the inscribed angle is equal to 1/2 of the intercepted arc. So meaning that 86 and CAT, the angle, is 43 degrees. So you just basically divide it into 2. For this next example, it shows that finding the value of the arc next. So this one for me is the easiest theorem because it is just half. You have just to divide it and multiply it. When finding the arc, you just have to multiply the angle. And when finding the angle, you just have to divide the arc. As it says, it is 1/2 of its intercepted arc, and the measure of the intercepted arc is twice the measure of the angle. So here in the solution, there's already a given. The given is the measurement of angle RAT, which is 52 degrees. So then our formula will be RT, arc RT, will be equal to 2, and arc RAT. Next, we move on to substitution. Of course, arc RT equals to 2. Let's not in parentheses, of course, never forget that. And substitute the given, which is 52 degrees. Now, since it says that it is twice the measure of the angle, we just have to multiply it. So here, we multiply 52 degrees. So our angle will be, arc, will be a total of 104 degrees. So here, in the first problem, it's just that you have to divide the given arc, and that is the answer of the angle. And here, in the second problem, you just have to multiply the given angle to get the arc. basic. Next will be our Theorem 2. So here in our Theorem 2, it says that if two inscribed angles of a circle intercept the same arc, then the angles are congruent. Now what does congruent mean? Well, congruent means it is both the same. So saying here, it says that angle ARD and angle AID both intercept arc AD. Therefore, our angle ARD is congruent to angle AID. Congruent meaning the same. So here in my example, there are already given values of the both angles, and we will just have to find the measure of the angle. So here we are finding the measure of our angle ARD. So first we must identify our given. What are our given? Our given first here is for angle ARD, we have 10x minus 4. And for our angle AID, we have 7x plus 2. So in our solution, we will be putting in angle ARD congruent to angle AID. So here we are finding the measure of angle ARD. So next we will be substituting the value of angle ARD, which is 10x minus 4 equals to the given of AID, which is 7x plus 3. I mean 2. So sorry. Next is, first we must minus the x's. Now here 10 will be minus to 7, which is equals to 3x, and 4 will be added to 2, which is additional to 6. So in overall, if we divide 6 and 3, we will have 2. So therefore our x is 2. And now we are finding the measure of our angle ARD, now that we have our x. So we will put in the value of angle ARD, which is 10 and 4. We will substitute the x of 10x minus 4 into 2, and then we'll multiply 10 by 2 minus 4 equals to 16 degrees. So our measurement of or measure of angle ARD here should be 16 degrees. Next we have our Theorem 3. Theorem 3 says that if an inscribed angle intercepts a diameter or a semicircle, then the angle is a right angle. Now, here we already have our given, which is our angle RAT and our arc RCT. Now it says here if arc RCT is a semicircle and line RT is a diameter, then measurement of arc AT equal 90 degrees. So what is a semicircle? A semicircle actually has a measurement of 180 degrees. And there are three actually measurements of a circle. When a circle has one revolution, it is the measurement of 360 degrees. And there is a semicircle, which is 180 degrees. And our quarter circle, which is 90 degrees. So it is basically shown here that since it has the diameter of RT, the line here RT is our diameter, and we have our arc RCT. Both those combined is a semicircle, which is 180 degrees. And this angle RAT combined with line RT, or the diameter, is a quarter circle, which is 90 degrees. So here in our example, we will be finding the value of x. So here in the solution, there is the measurement of CAT, angle CAT, and equals to 90 degrees. So we will be substituting the measure of angle CAT, which is there's already the given, is 6x. So substitute 6x equals to 90. Then x will be dividing 90 and 6, which is x equals to 15 degrees. So therefore our value of x would be 15 degrees. Actually, this one is pretty easy because it doesn't have that much solutions, and we will just have to find the value of x. Next is, lastly, we have our theorem 4. Here on our theorem 4, it says that if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So here it is shown that quadrilateral KCAR is inscribed in circle N. Then angle ARK plus angle CKA and is equal to 180 degrees, and angle CAR plus angle RKC is equal to 100 degrees. So meaning here, if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Well, that is exactly correct shown here in the example. They are supplementary here in the opposites. Next here is a problem that I will be explaining on how to solve. So here is a problem that we will be finding. So it says here that find the value of angle AUR. So as you can see, we already have two given. We have the given of angle RSO, which is 3y plus 12, and the given of angle AUR, which is 5y. Okay, so our solution here will be angle RSO plus angle AUR and equals to 180 degrees. So we will substitute the given. So it will be 3y plus 12 plus 5y equals to 180 degrees. And now for our y's, we'll be adding 3y plus 5y equals to 8y. And then 12 minus 180 degrees, which leaves us to 168 degrees. And here on our 8y and 160 degrees, we will divide them and we will get the y of 21 degrees. And thus our angle AUR will be 105. Actually, we will have to substitute the 5y since we are finding the value of angle AUR. So 5, substitute the y into 21 and then multiply them, equals to 105 degrees. That is all. Thank you.